Hi, good evening to all. Hello, my dear students. Today we are going to start the chemical properties, lecture number 6. Yeah. So, in this part, we are going to understand the Wurtz reactions and in detail about the Wurtz reaction with the mechanism. So, once you understand the video perfectly, this lecture, then please you subscribe my channels. Okay. My name is Hitesh Mishra. Let's understand that Wurtz reactions. See here. See students. Wurtz reactions. And what is this? Student, it formed that symmetrical alkanes, higher alkanes. What it formed? It formed symmetrical alkane and higher alkane, correct? So Wurtz reaction formed the symmetrical and higher alkanes. Now understand here, when we take that alkyl halide, 2 moles alkyl halide in the presence of sodium, dry ether. Why we take the dry ether, students? Because we don't want a moisture compounds, otherwise alcohol will form, correct? So therefore we take the dry ether. Dry ether formula, you know, ROR. This is called dry ether formula. So we take the dry ether so that the asymmetrical alkane will form. Now the point is, how the symmetrical alkane will form, how this compound will form, what the mechanism we will use it here. Student, we will use the two mechanisms. One is ionic mechanism and second is a free radical mechanism to obtain these compounds. So the first we will understand the ionic mechanism, that how to form the symmetrical alkane through the ionic mechanism, and second the free radical mechanism. Now the questions, why I teach you here? Student, because Wurtz reaction is based on the SN2 reactions and all the chemical properties we are dealing, which based on the SN2 and SN1 reactions. Okay. So here we understand that how that move in the ionic reaction mechanism. So let's understand the ionic reaction mechanism. See here. Student, first we understand the ionic reactions mechanism. Ionic mechanism. First we understand here ionic mechanism. So see here what will happen. Students, sodium will take. We take the sodium, and you know sodium, all the metals have a tendency to oxidize. So these sodium metals will oxidize. What will form? 2 moles of Na plus 2 electrons. Correct? The sodium metals will oxidize, all the metal will oxidize. So what happened? 2 Na plus 2 electrons. Now, when we take the Rx, the 2 electrons will supply to the alkyl group, so that the X will be a better leading group, as you know, that will lead the positions, and it will form the R negative. Understood, students? First what we have done? Sodium oxidized, and second step Rx, when we take, form the R negative. Now it is a strong base. It is a strong base as well as nucleophile. So it is both a strong base and nucleophiles. So keep in mind, we are using SN2 reactions. So we don't use the bulky base here, complex. Okay, and since it is SN2, so we cannot take here the 3-degree alkyl halide. Otherwise, it will move into the elimination reactions. So what happened? Now we have taken the 2 moles alkyl halide. Here is 2 moles alkyl halide. 1 moles is exhausted here. 1 moles is exhausted here. Second moles you have left. So next second moles are X. You have taken the base. So that base will attack from the back side. Halogen will leave the positions, and what happened? R plus X negative will form. Remember, 1x negative here. Student, 1x negative here, correct? And 1x negative here. How many x negative you have? 2x negative here. And how many sodium? 2 Na plus. Understood or not? Once it understand again. First, what happened? Sodium we have taken. Sodium, all the metal tendency to lose the electrons. So oxidized here. The 2 electron is left. Now the 2 electrons will attack on the alkyl halides on the alkyl position, so that the halogen will leave the positions and form the base and X negative. Now this base will attack on the second alkyl halide by SN2 mechanism. It means one is the inversion is possible. Second, don't take here the bulky group, because SN2 we don't use the bulky substances. So our base will attack on the alkyl compounds and then form the symmetrical alkanes. Understood? Now 2x negative and 2 Na plus, what will form? 2 NaX will form. Understood? This is the mechanism of ionic reaction which based on the SN2. Now we go to the next is a free radical mechanism. So this compound, Wurtz reaction follow the two mechanisms. Correct? One is SN2 and second is means ionic and second is free radical mechanism. Okay? So, okay, we understand here because it is very small, or just you write it so that we will understand here. Okay, see, student, one is, second is Wurtz reactions, and free radical mechanism. See here, free radical mechanism. So what happened? Free radical mechanism, students. See, Rx you have taken 1 mole Rx, that will here dissociate or broken into the R plus plus X negative, and sodium tendency to lose the electrons, correct? Now here alkyl group, now alkyl plus, that will take the electron from here, and what happened? It is a R free radical group form. What happened first? Rx will dissociate into the R plus plus X negative, and second sodium has tendency to lose the electrons. Now one electron is taken by the alkyl groups, cations groups, and form the free radical substances. Now this free radical will attack on the next alkyl halides, or simply you understand same process will be happen for second alkyl halides. This is the first alkyl halide, and the similar things will happen for second alkyl halide, exactly same thing. If you take the second alkyl halide, same thing will happen. Rx, R plus X negative, Na, that will dissociate Na plus electrons, and then what happened? R plus electron from the R free radical. Okay? So, since we have taken the 2 alkyl halide in the Wurtz reaction and the 2 moles of sodium, so 1 mole sodium, 1 alkyl halide generate the 1 free radical, second mole alkyl halide and second mole of sodium generate the another free radical. So what happened? Now, I write here, where I write. Now here is R free radical and here is R free radical. So what happened? I write here R free radical plus R free radical, what happened? R will generate symmetrical alkanes. Students, here is one thing is very important. First you write all these things, then we understand. Here is two things happen. RR is formed, this is called dimerizations. Correct, na? RR form is called dimerizations. See here. Okay, you have written that? Fine. See here. What I am telling you, in those reactions, two things will happen. Understand here? One is, see, you have taken the 2 moles alkyl halide, 2 moles of sodium. What you have got that? RR symmetrical alkane plus 2 moles of NaOH. This is called dimerizations, correct? So dimer is formed. Remember one thing, apart from dimerizations, disproportionation is also involved. What? apart from diagonalizations, disproportionation is also involved. Let's understand here. Student, we take the one example. Suppose we have taken the CH3, CH2, Cl. Okay, 2 moles plus 2 moles. Here we will get the CH3, CH2, CH2, CH3 will form. Correct? But do you know one thing? In the free radical mechanism, what we have done? In the free radical mechanism, CH3, CH2, what happened? That will form cations plus Cl negative. You have taken the one sodium. So one sodium, what will generate? Na plus electron. Now what happened? CH3, CH2 cations. These free electrons will be given to this ethyl carbocation. So that what happened? CH3, CH2 free radical will form. Okay? Student, similarly, you have one more moles. You have same compounds. So what happened? Same free radical will generate. Are you getting or not? 1 moles we have taken, the ethyl free radical is generated. Second moles we will take, another free radical will generate or not. So once more free radical will generate, CH2H and CH2 free radical. Can I write this compound in the same way? So that what happened? The free radical will attack here and it will form the CH3, CH3 first, and once the hydrogen will remove, here free radical will come. Once the hydrogen will remove, here free radical will come. So that free radical what will form? CH2 double bond CH2 is formed. Understood or? So student, 2 compound is formed here apart from the symmetrical. So symmetrical alkane is formed. This is called diamerizations. We have more than 2 compounds, or 2 compound is formed. It is called disproportionation. So this is a disproportionation. Okay. Student, now the question is, so when dimerization is formed, student, dimerization is formed when the activation energy is low. Activation energy low means reaction will be very fast. Okay, chemical kinetics, if you have done that, activation energy low means there is a very high rate of reactions, correct? And if that disproportionate reaction is formed when the reaction is very complex, means when the alkylide is tertiary alkylide or complex alkylide, then probably the disproportionate reaction is disproportionate reaction undergoes. But you keep in mind the Wurtz reaction undergoes into the 2 process. One is dimerizations and one is disproportionations. Okay. Now the question is here, sir, what will happen when the nucleophiles and alkylides, or you can say the base and alkylide, both will take on the same compounds? What will happen when base and alkylide will take on the same compounds? Then what will happen? Let's understand what happens. See, so I hope you understood the Wurtz reactions in the both the mechanism, free radical and ionic mechanisms. Okay, and how many product can form? Just one thing one keep in mind: if we take the 2 different alkylide, RX plus R dash X plus 2 moles of Na, 3 product will form: RR, R dash, and RR dash. What? 1 RR, 1 RR, second R dash, and third R dash will form. Correct or not? So 3 product is formed. Okay. So let's understand what happens when the base and alkylide both present on the same compounds. Okay. That will move into the intramolecular Wurtz reactions. See students, what will happen? That is the intramolecular Wurtz reactions, and actually there are questions already came in that NEET exams, even though IIT mains also. See here, what I ask you, suppose you have a OH group here and CH2 students in Br, okay, and you have taken the sodium diether. What will happen? Understand here. Student, here is the acidic hydrogens, correct? Yeah? So keep in mind, in any compound if there is acidic hydrogens, the different product will form. Okay, so here is acidic hydrogens. So sodium will attack here, and what happened? NaO, Na plus O negative, CH2, 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 and Br will form. Now you remember it is a negative charge, so base that will attack here because it is acidic hydrogens. So once it will attack, bromine will leave the positions because it's good leaving group. So what happened? Now 1, 2, 3, 4. So O, you know this compound, what will form? This is called THF, tetrahydrofuran. So THF will form. This is called, that compound is THF will form. Once more, see here, HO, CH2, CH2, okay, and Br, same thing will happen. What will happen? NaO, CH2, CH2, Br. Student, it will attack here, plus and minus. So what will happen? O, this type of compound is formed. Are you getting or not? Okay. Now next we understand this is called intramolecular Wurtz reaction, students. 2, 3 more examples we understand here. This is intramolecular Wurtz reactions. Now we understand 1 and 2 more mechanism here. 1 and 2 more example. Okay. See here. I give the one more example here. What will happen? Think about it. Student, here is the compound I have taken. Here is the bromine and here is the chlorine. See, in the one compound, one is 2 halide group is there. Okay. So, so 2 halide group, what will happen? This is the intramolecular Wurtz reactions because we have taken the 2 moles of sodium. Na? So, what happened? So, NaCl and NaBr will leave the positions, and what will happen? It will form this type of compounds. Clear or not? Suppose you are taking here Cl, CH2, CH2, okay, CH2, Br. What will happen? When we take the 2 moles of sodium, okay, so that means it will form these compounds. Are you getting or not? Suppose you are taking these compounds here. Here is a chlorine, here is a bromine. What will happen? And we have taken the 2 moles sodium. So 1 chlorine, 1 bromine generate another double bond here. So it means here is already 1 bond, and chlorine and bromine generate one another bonds. Understood or not? This is what we can say intramolecular. It is called intramolecular Wurtz reactions. Okay. So students, keep in mind, here is the 3 important points. Wurtz reaction can give the dimerization product and disproportionation product. Okay. When the activation energy is low, dimerization product will form. When the reaction is complex, or when the 3-degree alkylide you have taken, or you can say that, in that case disproportion reaction will occur. Okay. And the third, when you have taken that base and halides on the same compounds, or 2 halides on the same compounds, that will move into the intramolecular Wurtz reactions. So this is the example of intramolecular Wurtz reactions. Okay. Students, once you understand perfectly, you got that perfectly, please subscribe the channels, which help me, which encourage me to make a more video for you. Thank you so much. Have a nice day.